Welcome to lesson 4.3, Prove Triangles Congruent by SSS. So the first thing we want to do with this title is make sense of this 3S part, or SSS. And where that comes from is postulate 19. Postulate 19 is the side-side-side congruence postulate, or we shorten that to the SSS congruence postulate. And what that postulate states is if three sides of one triangle are congruent to three sides of a second triangle, then those two triangles are congruent. So if three sides on one are congruent to three sides on the other, those two triangles are congruent. So we're going to apply that in example 1 to begin with. So they're saying decide whether the congruence statement is true. So a congruence statement is just this piece right here, where it says triangle LMN is congruent to triangle UVW. This piece is known as your congruence statement. Now remember, what they're doing is matching up corresponding parts. So they're saying triangle ABC in part A is congruent to FED. So that means A corresponds with F, B with E, and C with D. So that means AB should be as long as FE. So let's check that. Well, AB has 3 hash marks, same with FE. So we know AB and FE or EF are congruent. Then we also know on the side, from B to C, that segment has 2 single hash marks. From D to E, that also has 2 single hash marks, meaning those are congruent to each other. So BC is congruent to ED or DE. And then we also know DC, this little piece here, is congruent to itself. So then with the info that AD is congruent to CF, and this distance is the same, we know the distance from A to C is congruent to the distance from F to D. So we know AB is congruent to EF, BC is congruent to ED, and AC is congruent to FD. So we have 3 corresponding sides that are congruent, so this congruence statement is true. In part B, LMN congruent to triangle UVW. So that means L corresponds with U, M with V, N with W. So I need to make sure that MN is congruent to VW, that LN is congruent to UW, and that LM would be congruent to UV by matching up corresponding parts. So let's look at our info. We knew NM was 11. Distance from N to M was the 6 plus the 5, so I got 11. Then I'm checking if that's the same as VW. V to W is also 11, so we know those two are congruent. U to V, so from U to V is the 3 plus the 6 or 9. And then on the other one, L to M is also 9, so those are congruent and match up. And then lastly, we're looking at the UW here, which is 5, and the LN, which is also 5. So LN's congruent to UW, 3 congruent sides, so this is a true statement. Triangle LMN is congruent to triangle UVW. And then our last one, part C, triangle PQR congruent to triangle RTS. So that means PQ would correspond with side RT, QR would correspond with side TS, and then R to P would correspond with S to R. So let's check those. RP on the bottom, 2 hash marks. SR on the bottom, 2 hash marks. They are congruent. P to Q, 3 hash marks. T to R, 3 hash marks. They are congruent. Q to R, 1 hash mark, T to S, 1 hash mark, meaning those two are congruent. So this is a true statement. Then we get to the example 2 part, where it's asking, based on the coordinates, can we determine if triangle ABC is congruent to DEF? So they gave us the coordinates for triangle ABC at 1, 1, negative 4, 2, negative 2, negative 4. So I graphed that and drew triangle ABC. Then DEF was at 4, negative 2, 9, negative 3, and 8, 3, so roughly in this area. Now, how do we figure out the length of the sides when we weren't given anything other than coordinates? Well, we're right back to using the distance formula from the beginning of the year. So the distance equals, all underneath the square root, x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. So you're going to use the x and y values for each of these distance setups. So I want to figure out the distance from A to B, or the length of side AB. So the change in y values from A to B and the change in x. So change in x would be 1 minus a negative 4, which is a positive 5. Change in y would be 1 minus 2, which is a negative 1. 5 squared and 1 squared is 26. So the distance from A to B is the square root of 26, or approximately 5 point whatever the decimal is. I'm just leaving them underneath the square root sign to see if they're equal. Then if I do the same with DE, change in x values for DE, 9 minus 4 is 5. Change in y values, negative 3 minus a negative 2 is a negative 1. So the distance from D to E is also the square root of 26. So we have two sides that match up. So far, so good. Then we're going to do the same with the other two sides. So CA, you can see, is right here. Came out to the square root of 36, or 6. BC, our third side of that first triangle, came out to be the square root of 40. And again, you're using the coordinates from B and C for this one, coordinates from A and C for this one. Then we need to finish out the other triangle, so FD and EF. Well, there, in ABC then, I have only one side that matches up with a side from DEF. The square root of 36 and square root of 40 do not match up with the square root of 37 and square root of 41. So these two triangles are not congruent. If we ended up with the same distance for 3 sides on each, then those two triangles are congruent. And then when you write the congruence statement, just like up here, you need to make sure you match up corresponding vertices or letters. Then the last example for today's lesson is the proof. So in this proof, they gave us all the statements. They did not complete the reasons. So let's look at our proof to begin with. It says side AB, or segment AB, is congruent to segment CB. And then they also tell us D is the midpoint of side AC. So D splits AC in half. So they started their statements by splitting the two parts of the given, which is fine. You could write it all as one. So reasons 1 and 2 are both given. That info came right from our given statement. And then they went on to say segment AD is congruent to CD. So AD here is congruent to CD here. How did they know that? And how were they able to say that? From this line right here. If D is the midpoint of AC, that means AD is the same distance as DC, or those two segments are congruent by the definition of a midpoint. Then they told us that segment BD is congruent to itself. Anything equal or congruent to itself is the reflexive property. So in this case, because it's a congruent sign, it's a reflexive property of congruence. And then they now know BD is congruent to itself, AD is congruent to CD, and AB was congruent to CB. So they can state that triangle ABD is congruent to triangle CBD using the side-side-side congruence postulate. And again, you can ignore the page numbers down here, go with the ones that are posted in Google Classroom with the assignment. So the main idea goes back to just this very first postulate. If three sides of one triangle are congruent to three sides of a second triangle, then those two triangles are congruent to each other.